In this video, let's discuss greedy change. First off, let's define what is a greedy algorithm. So fundamentally, we have an algorithm paradigm which makes the optimal choice at each step, and that is to be contrasted with considering all sequences of steps. So in greedy algorithm, we are just considering each step as it attempts to find the overall optimal solution for the whole problem. A rough analogy could be from a saying like, don't think about what can happen in a month, don't think about what can happen in a year, just focus on the current step, which is in this case 24 hours. And hopefully you can get an optimal outcome for the whole duration. So for example, we have a greedy change. Consider the problem of making n cents change with quarters, dimes, nickels, and pennies, and using the least total number of coins. So at each step, you have to focus on the largest amount first before you proceed with the smaller amount, and so on. So we come up with a pseudocode for this. So let's just call it greedy change. And input arguments involves the amount, say the money. Let's just have the x for the amount, and the coin denomination as well, composed of n elements. So for the input to the algorithm, input parameters is the amount of money, say this is the amount of change, and the coin denomination will involve set, say this is denomination 1, denomination 2, and so on up to n. And we put a constraint that D should be the largest. So where D1 is greater than D2, and so on up to Dn. So D1 is the largest denomination. And we could simply come up with counting. So our output will be the count. Minimal coins. So where do we place the body of the algorithm? This is simply a for loop, so let's put the body of the algorithm. So let's make this white. So I'll just put the body of the algorithm on the top. So let's come up with the body of the algorithm. So I will simply assign, firstly I will assign 0 to my y, and I will come up with a for loop, say for I from, say, let's assign something to y. From 1, so this will handle the denomination 1 up to n. We will simply get the count for that. So for the first denomination, we will count it as this is basically the change, which is x division div div the money denomination, so div d sub I, and this will give the largest. For example, if the coin denomination is, maybe the largest is 25, so the first one will be 25, followed by 10 cents and 5 cents and 1 for penny. So after this, we are going to update our change with the remainder. So the remainder, which is x modulo with our coin denomination. And basically this is it. This is already the solution. And afterwards we will end the for loop. So this is the body of our algorithm. Heading for this is a greedy change. It takes an input amount of change x, and coin denomination. This is an array of coin denomination, and for example, you have an input x amount, the amount of change, the coin denomination. Output is the minimal number of coins that is used for the change. And for the first part of our algorithm, we simply initialize the minimal count to 0, and then we will loop through all the coin denominations and count with respect to division, integer division, for every coin denomination. And we will update the change by simply getting the modulo operator. And that's it. So that's the solution for the problem. For example, if we have a task to design a program for a vending machine utilized by LRT or MRT beep card users for reload. The user inserts a certain amount of money and decides how much to load. Assuming that the amount to be loaded to the card is smaller than the inserted money, design an algorithm that returns a minimal number of coins to the user. Give the pseudocode for the algorithm. So basically this will involve the same heading. We have a graded change with slight modification. So this version, our graded change accepts so the greedy change here accepts the inserted amount, say we'll call this I, maybe just inserted INS, inserted amount, the amount to be loaded, so maybe I'll just call this load, and the coin denomination, of course, in which case we have 1 2 3 4 5 6 7 8 9 values for the denomination. Again, for our input, let's clarify that INS is the inserted money, and load, or this is still input, so load is the amount to be loaded, finally the coin denomination has a certain order. Say this is 1,500 and so on up until 1 peso. So for the output, same output, we are looking for Y, and that Y is the minimal amount of money or minimal amount of bills / coin. Again, this will be similar to the one we had earlier, so let's just assign or initialize our count to 0. I think I'm out of space, so I will compute the change, introduce a new variable, maybe change. So change will be the difference between the inserted money and the load. After that, I'll just loop from I, so 1 to we have 9, 1 to 9, and compute Y is Y plus the change modulo or diff, so change diff the money, so D sub I, and update the Y or update the change, so change will be the change modulo D sub I, and that's it. After that, we'll have to end 4, so end 4, so this is 3 4 5 lines. 5 lines of pseudocode. So we could express this in an actual code. For example, if we code this in Visual Studio, so we will have something like this: greedy change and inserted amount, inserted money, loaded money, or the money to be loaded, and we have the money denomination, say 100 peso, 500, 200, and so on. So initialize the count to be 0, and then afterwards so this is very similar to our pseudocode earlier in this form. So you have inserted money, loaded money, and then we compute the change, and then for loop div, and then update the change with the modulo operation. So we have this main loop here where we get the count with simple division, integer division, and the change with the change update for the change with modulo operator. So let's try this code and see how it works. So basically I simply tested it with a simple prompt to input the values. Say how much inserted money is there, so for example we inserted 1,000 pesos and we want to load say 300. So if the change will be 700, so it will amount to 500 bill and another 200 bill. So the minimal number of bills will be just 2. Okay, and it works. But let's try this again. Let's insert maybe 100 peso bill, and let's how much do we want to load? So let's just load 33. So the change will be 67, and we have how many? So 150 peso, 110 peso, and 5 peso, and 1 peso bill. So I expect a 5, and 5 it is. That's it.